Why don't you guys just give me a little bit of background? I'll tell you a little bit about myself.
I'm 17 and I'm attending University of Michigan in the fall for neuroscience.
Awesome.
So,
Welcome. And your name is?
Elizabeth.
Elizabeth.
I'm Barbara. I am the science teacher at Da Vinci.
Oh.
I don't know where in this direction of this building, but over here on
Awesome.
campus. I'm primarily biologist. I'm about 85% biologist and about 15% chemist,
Okay.
budding chemist.
Uh-huh.
So I'm really interested
Yeah.
in health and in public health too, and I talk a lot about that with my students.
Awesome. So my name's Matt. I teach. I'm also kind of biologist, chemist. I teach down in Lenawee at our satellite campus down there, and I'm full-time down there and do all the science besides anatomy and physiology, basically. So, before I came to JCC, I taught at a small liberal arts college, and one of the courses that I taught there was called 12 Diseases That Changed the World. And it was all about the impact of infectious diseases and how they change history in a lot of different ways. And so I've always been kind of fascinated with public health and specifically influenza. And so when I was thinking about what kind of topics I'd be interested in presenting on, this is kind of what came to mind. And so bits and pieces of this is from some of the materials that I've presented before. A lot of it is from this book. John Barry wrote this book called The Great Influenza. Really good read if you're at all interested in the topic. If you get to the end and you think, well, that's kind of cool, I'd like to read a little bit more about that. That book is really good, and it's not at all sciencey. So it's very written for everybody to be able to make sense of it. But anyways, I just wanted to take you through a little bit of the information that I kind of had put together when I was teaching on this stuff, and the things that I found really fascinating about the 1918 influenza. And so, to start off, I really think we need to think back to what was the world, specifically what was the United States like in 1918. Okay, and so there's a couple of things just to kind of put you in the right frame of mind. There's only about 92 million people in the country at that point, so very, very different. Average salary was about $750 a year. It cost 32 cents for a gallon of milk. The national debt was only $1 billion, so that tells you something. So a very, very different time, almost 100 years ago now. The latest fad at that point was dancing. So everybody really enjoyed doing when they had free time. So that's a picture from 1918. But where the story of influenza really starts is Haskell County, Kansas. And this is a picture of something called a sod house. If you would have went out into Kansas in 1818, you would have seen these sod houses, basically houses made of dirt, because that's what they had. People that had small farms, plots of land. And at that point, a local rural physician, which in those days those people kind of did everything, started noticing cases of people that had very, very severe respiratory issues, pneumonia, things like that. And that's suspected to be what would eventually become the Spanish flu. So first of all, I'm going to tell you a little bit about the virus and about the disease, because there's a lot of misconceptions that people have about influenza, about viruses in general, so we'll talk a little bit about that. And then look at specifically 1918 flu, and what were some of the reasons for it to be so bad. You had a disease that ended up killing 100 million people, infected probably 25% of the United States, killing about 5%. So you think about 1 out of every 20 people was killed by the virus. So why was it that bad? And we can finally then think about, is it possible to have something like this again? First of all, what is a virus? So a virus is our simplest organism that we know of. It basically has two things: genetic material in the middle surrounded by some proteins. That's it. It's not really even considered alive. It can't respond to a stimulus. It can't move towards or away from something. It just gets into a cell, takes it over, gets out of the cell, and goes to the next one. Very, very different from bacteria, and even more different from our own human cells. So, one of the things I wanted to mention in regards to this virus in particular, which you're looking at, this is influenza virus, are these two proteins that are spikes on the surface that you can see. Those yellow and purple spikes are two different proteins. One's called hemagglutinin, the other is called neuraminidase. And they are abbreviated H and N. And so, one of the things that you guys might have seen if you've ever been looking in the news or listening, you'll hear somebody say like H5N1 or H1N1. And maybe you've wondered, like, what does that mean, that like H and N? It has to do with the fact that those spiky proteins, there's different versions that are found on different viruses. So there's 16 different forms of H and 9 different forms of N that we know of. And they can recombine and reassort to make different viruses. And so you guys have probably heard of H1N1. There was an epidemic in 2009. Fortunately, it was not very pathogenic. It didn't kill a lot of people, but it was very infectious. A lot of different people had it. That was also the same variety that caused the Spanish flu in 1918 that we'll talk about. You guys have probably heard of H5N1, or avian or bird flu, and we've had several outbreaks of. And then there's a couple other ones. This H7N9 is brand new. Just last month, for the first time, we started seeing people that were becoming sick with that in China. So we've got all these different versions, but the H1N1 is the one, what you might think of as swine flu when you hear about that. Why is it called swine flu? Because usually these are viruses that are able to be infect pigs and able to be grown in pigs. But interestingly enough, most of them began in wild bird species. And wild birds, when they come in contact with domestic birds, specifically chickens, can transmit the virus. And then those chickens, if they come in contact with pigs, and in places like Southeast Asia and other countries like that, we have a lot of very, very small families that have a couple different animals of various varieties. So like in China, for example, a family will have a couple chickens, a couple pigs, and then the people all living together. And what happens is you get this problem where you have virus from chickens that can infect pigs, viruses going around in people that also can infect pigs. And so the pig becomes kind of an incubator. You can get this reassortment, this change in the genetic material that occurs between the viruses, and what comes out is sometimes a virus that's able to infect people, but has some of the characteristics of the bird or swine influenza as well. So, this is my one comical picture. Whenever I think of talking about swine flu, I always have to put this picture up. But how is influenza transmitted? We know that it is inhaled, right? So this kid's not going to get influenza from something like this. It's inhalation that is the transmission. So virus gets into the air, we breathe it in, it gets into our lungs. And some of the symptoms, think about when people tell you you're having flu-like symptoms, right? What are those things? You feel very weak, you feel really tired, you might have a sore throat, runny nose, but it's that achiness that you don't want to get up. You know, getting up to go to the bathroom is a struggle. That sort of achiness is what we usually think of with our seasonal influenza. Not the same as the common cold, and that's something that you'll hear a lot of people say. Oh yeah, I was kind of sick this weekend, I had the flu. No, you didn't. You had a cold, right? Probably caused by another virus, like rhinovirus or something like that. But if you had the flu, you're in bed for days, and that's really influenza. So, we know that, especially in the very young and the very old, we can have complications. The biggest thing is really pneumonia, and that's a bacterial infection in the lungs. So the virus gets in there, starts causing damage to the lungs, and that can open it up for bacteria to come in, and those bacteria can cause some additional symptoms. But one thing that always surprises people is we have about 200,000 people that go to the hospital every single year just from seasonal influenza. Nothing special, we're not talking about H1N1 or H5N1, just your standard flu is putting 200,000 people in the hospital, killing about 36,000 people every single year. That's on a standard year. So it's actually a fairly deadly disease, but it's usually the very old, the people that are dying from this. Now, one of the important things that, as an educator, it's really important to get the word out on is that, of course, we don't want to think about antibiotics as our treatment for a viral infection, right? Antibiotics are not going to work against a virus. Antibiotics are great for bacterial infection. They're not going to do anything for a viral infection. So antibiotics are not the answer. Antibiotics are not the treatment. We do have a couple of drugs. You guys have probably seen the commercials for this drug called Tamiflu that's out there. Tamiflu is available. However, a lot of physicians are going to be very hesitant to give it to people because we know that just like in bacteria, you guys have heard of antibiotic resistance that can develop amongst bacteria. With viruses, we can have the same problem where we can have resistance that can develop against drugs that are out there. So we want to be really careful about how much we're giving out these drugs because we don't want resistance to develop, because we really only have a couple of drugs that work against the virus. So this virus has been around with us for a long, long time. Symptoms were first described as far back as Hippocrates about 2,400 years ago. There's been a couple major epidemics. Epidemic means a lot of people infected in a very short amount of time. So Asian flu in 1957, Hong Kong flu in 1968. These are situations where we had the virus that went to multiple different countries, spread itself around the globe, killing 1 to 2 million people. What we're talking about is Spanish influenza, the Great Influenza of 1918 to 1919, H1N1 virus. Interestingly enough, one of the things I never knew until I started looking into this was, why is it called Spanish influenza? Did it start in Spain, or what the deal was? Actually, no, what the real issue was, and this is something that we'll get into, is a lot of the newspapers and press of the time were very reluctant to be truthful about how nasty the virus was and how many people were dying from it. There was only one country that had a real independent media that would actually report what was happening, and that was Spain. And so Spain was the country that really started putting the word out about how nasty this epidemic was. Because of that, it came to be known as Spanish flu. Now,
So it wasn't epidemic only in the United States?
No, it
Okay.
actually went around the globe 3 times
Okay.
between 1918 and 1920. So some really interesting things, totally unique about this epidemic. One, obviously it killed 5% of the global population. That's a problem. The infection rate was near 50%. That's very high for an infectious disease. You figure there's going to be a fair number of people that are going to be susceptible, but many others that will not. Something close to 50%, that's pretty impressive. The death rate was anywhere between 2 and 20%, depending on where you were, different populations. But the weirdest thing by far about H1N1 in 1918 was that you had some of the greatest rates of death amongst people that you would think would be the healthiest in our population. People aged 20 to 40 died at a higher rate than those younger and older than that. It's just bizarre, okay? And one of the things we're going to talk about is, why the heck is that? Because that seems so contrary to what we would normally think. You would think these would be the people that would be the healthiest. They're going to be the strongest people. Yet look at this rate. This is the death rate, okay? So we're looking at the specific death rate in our different age groups. And look at that spike, right in that 25 to 34 age group. Okay, right where you would normally anticipate that dotted line, or that dashed line, is what the death rate was in influenza the 6 years before that. Okay? And look at that's a death rate that is pretty standard. You would expect that. The really, really young and the really, really old are really susceptible and are going to get sick and die. Those in the middle, very, very rarely. 1918 was totally different. Oops. So, really 4 things contributed to why this was probably on the order with the Black Plague. Those 2 are probably our worst pandemics that we've ever experienced. Pandemic is just an epidemic on a global scale. When it goes around the world, we call that a pandemic. This one was one of the worst, and it was really due to these 4 things. So first of all, we had something going on, World War I at this time, that really contributed to this epidemic. So I told you guys that some of the first reported cases of this really severe influenza was reported in Kansas. Well, at that time, lots and lots of people, thousands of people were coming together from all over Kansas, and they were coming to military bases, okay, that looked a lot like what you're seeing in that picture, okay? The problem with the military bases is, of course, you've got a centralized base, you've got thousands of young men coming together from all different parts of the state, living in really close quarters. I mean, look at how close those tents are. You probably have, 4 people in each of those tents, coming in close contact with a lot of other people. We know this is a respiratory virus. We start to get spreading amongst people in these military camps. Then what happened next was, where did all those soldiers go? They went to the front lines in Europe in World War I. If you know anything about, well, here's another picture of those training camps. If you think back to what was war like in World War I, it was trench warfare. Okay, so you had thousands of people in these long trenches huddling together, right? And you would storm and try to go over to the next fence while other people had machine guns shooting at you. Okay, this was what was happening at this point. Lots and lots of opportunity for people to be coughing, breathing, right? These people are, this is during the winter, right? These people are freezing in these trenches, so they're huddling together for warmth. People are getting sick, they're spreading influenza. And so this starts to get spread now throughout Europe. When the people get sick, if you guys have ever spent any time, seen anybody at a hospital nowadays that has MRSA or C. diff or anything like that, there's all these precautions, they're in a closed off environment, all of these type of things. This is what would happen if you were sick in 1918. You'd go to the military hospital, right, and you had basically nothing between you and the person next to you. So if you were in there for some other reason, and the person next to you had influenza, then you had influenza. And so this began to spread. Now, of course, the people that should be dealing with this once this would start to spread would be our physicians, okay? But the problem is that science-based medicine had really only begun in the United States in about 1900, okay, which is pretty shocking. That was only about 100 years ago. But before that, we had thoughts on that diseases can be caused by things like an imbalance of your 4 humors. And so you would hear of things like people would do bloodletting as a treatment, or they would give people mercury. Okay, that would make them throw up. And they thought they were rebalancing their humors. And that's what would cause people to be sick. And then if you would take away some blood or have them throw up, get rid of some phlegm, that would rebalance those humors and then they would get better. Well, we know that that's not the case, but this is where medicine was at, okay? Now, we had some physicians that were trained professionally in these science-based methods, but where was their top priority? Over in Europe, helping the soldiers. And so all of our newly trained physicians all went over to Europe. And so who was left back at home to deal with the epidemic? It was the older physicians, the rural physicians that had not had this science-based training. And so that was the other problem, is that our modern methods of treatment, things like isolating people and making sure they had lots of fluids and rest and things like that, those were not the things that were done. The other huge problem was we had no central source of information. Okay, nowadays we have the CDC. You guys have heard of the Centers for Disease Control. That's putting out information constantly on H5N1 or H1N1. And so we're hearing about these things all the time. We're getting correct information about what we should be doing and not be doing. Okay, there was nothing like that. The CDC wasn't created until the 1940s. So we didn't have any central source of information. And so anytime you have a vacuum like that, it gets filled in with hearsay and people hearing this from somebody else or something. And so we don't have good information on what to do, okay? A lot of people ended up dying simply because people were so scared of coming in contact with everybody else that they wouldn't do that. So here's an ad. My daughter will die from need of a nurse. Won't a nurse please come? Salary $50 per week. That's just a poster about making a mask. It's debatable whether masks really have much of an impact on preventing influenza. Think about how tiny a virus is, much, much smaller than a bacteria. They might have some impact. That's still kind of up for debate. Having people make their own mask at home, probably not the best thing to do. These are all examples of pictures from Philadelphia in 1918. Philadelphia probably had some of the worst of the outbreak. But here's some of the problems, okay? This picture is taken at the height of the epidemic, okay? What do you guys see? What's wrong with this picture?
All these people
We
out
have
there.
thousands of people, right? And so we have an epidemic going on, and yet it said, here's this war parade, everybody come out, okay? And so we have thousands and thousands of people coming out together, some of which are sick, infecting other people. So there's nobody to say, hey, we shouldn't be doing this. Now, eventually, it started to get really bad, and it got really bad in Philadelphia. On a single day in October of 1918, almost 800 people died, usually about 500 dead a week. Society broke down, okay? Nobody goes to work, therefore there's no food available. You go to the store's not open, there's nobody there, there's no food in it. Nobody would talk to each other, nobody would help each other out. People were so scared about this disease that literally there were stories of families that would starve to death because they were too sick to go out and get food and water, and no one would help them because they were terrified of picking up the infection. When you don't have communication, this is a huge public health lesson. When you don't have anybody to give people information, that a lot of times will lead to even more problems and more people being killed. So here's some of the things that started happening. So you see signs up. People thought maybe spitting would have something to do with that, and so there are signs, don't spit. Here was one. Get some lemons. Okay, these were some of the suggested things to do. Spanish influenza doesn't like lemons. Lemons are said to be flu foes, etc. So you're supposed to go get a lemon, and that will help you recover from the flu. Maybe this loves something too, vitamin C or something, but probably not. Read this. This is published in, I think, Philadelphia. Okay, it's too late now. The best counsel we can give to the public is to get as much fresh air and moderate exercise as possible. Keep away from crowds, so that's good suggestions. Keep their houses clean. The surest way to catch any prevalent epidemic is to worry about it or be afraid of it. Okay. So they're starting to get the idea that it was a little bit too late at this point. So what you had was an epidemic that went first in the United States, then to Europe, then to the rest of the world. Then it came back. The first time it was pretty infectious, but it wasn't very deadly. The second time it came through a year later, something had happened. Something had changed in that virus, and it was now incredibly pathogenic. And so what I want to tell you is just a couple slides about what actually it was that was unique about the 1918 virus. Why were so many more people killed by this? One of the big things was where the virus went in the lungs, okay? An 1818 influenza would travel to the lower parts of the lungs. If you look at those images on the right, the purple is where the virus goes, okay? At the top, that K173, that's a standard influenza strain, okay? Notice that it mainly stays in the top part of the lungs. Okay, that's good. Your immune system can clear that out easier than the lower parts of your lungs. Look at 1918, it goes in the lowest parts of your lungs. Very, very difficult to get rid of the virus out of there. And so there were stories of not only hemorrhaging, you have a lot of people that would, literally their lungs would start to fill up with blood from hemorrhaging, and people would turn blue because even though they were breathing, because they have blood and other things in their lungs, the oxygen wasn't actually getting to any of their tissues. So you watch people turn blue after infected with this virus. So it was really unique. Normal influenza doesn't do that, okay? Now back to this question. Why was it that this group, 25 to 34, was killed at such a higher rate than everybody else? Well, in the end, what people found out when they have done research on this is that the reason that those people died was because the virus triggered a very, very strong immune response. So our immune system is normally really, really good at getting rid of pathogens and things like that. The problem is sometimes pathogens can turn it on a little bit too much, okay? Kind of like, the volume should be up at like 7 or 8 normally, and these, would cause the immune system to crank it up to 11, too high. Of those age groups, guess which is the group that has the strongest immune system? It's those people 20 to 40. That 25 to 34 age group has the strongest immune system, and therefore, when there was this hyperactive immune response, those were the people that suffered from it. So it was because of this huge immune response that was triggered by the virus. And this is just looking at, again, the reds and blues are indicative of places where the immune system is attacking the lungs, and you can look at the huge difference there with the 1918 virus versus our standard virus, the K173. So it's really where in the lungs did the virus go, and how much of the immune response, it kind of triggered the immune response to attack the lungs itself. So here is a picture of over 1918 and 1919, the different deaths in New York, London, Paris, Berlin, okay? And so what I want you to see here is, don't worry about specifically what lines are what, but notice that we had, in early 1918, we had a low number of cases, but there was definitely a wave there. And then it was in the fall and winter of 1918 and 1919 that we had a huge spike in mortality. And then there was even a third wave into 1919 as well. And so this was also amazing in the amount of time that it was around causing people to be sick. Normally we think of seasonal influenza, right? There's like a month, maybe a couple weeks that it gets really bad, and then it always gets better. Not so. This went around and it kept going. Now, a logical question then is, well, why didn't it just keep going? What eventually caused it to stop? because it did eventually stop in late 1919 into 1920. And it simply it burned through the population. The people that were susceptible, it killed, and the people that weren't were resistant to it. And that's usually what happens with these very severe viruses and things like that, is it kind of burns itself out. And that's what influenza did. It killed the 5%. The other group either recovered from the infection and then, for the most part, they really wouldn't be susceptible to infection again, or they were resistant in the first place. And there was no one else for the virus to infect, just like a fire that runs out of wood, fire goes out, same kind of thing. This is kind of interesting, you know, there's so many impacts from influenza, but this is the life expectancy of people in the United States. And look at that huge dip. If you can tell what year that huge dip occurred, that was from 1918 influenza. It dropped our life expectancy in this country about 15 years. It killed so many people. So if you notice, it took another, 5 years maybe after that for the life expectancy to recover. It took many more years than that for our actual population in numbers to come back up. So, if we would have had a population, remember we only had 92 million people, okay? If we would have had population that we have today, where we have about 6 billion globally, we would be anticipating anywhere between 100 and 300 million dead. One more thing, do you want to wrap up by about 2:30 so you guys can get to another session? One more thing that I want to mention is, I've been telling you some different pieces of information about the 1918 influenza virus, and maybe you guys were thinking, how the heck do we know anything about 1918 influenza, right? We didn't even know at that time that it was a virus that was causing this. Okay, this is another whole part of the story that we don't have time to get into, but nobody knew it was a virus. We didn't even know what viruses were. Nobody ever looked at a virus under an electron microscope until the 1950s, 1960s. Okay, so nobody has any clue. Okay, they started opening people up, and they found a bacteria in there, and they thought, that might be it. It was just a secondary infection that was coming in after the virus. But we had no way of culturing viruses. We had no way of even knowing. So anyways, how do we know anything about 1918 influenza then? Well, in about 2002, 2003, a bunch of people were found in a cemetery in very, very northern Canada, okay, in permafrost. Okay, the bodies that were buried there had been there in permafrost ever since 1918. And so somebody came up with the idea, if you guys have ever seen Jurassic Park, it's a very, very similar idea. Why don't we go see if we can find the genetic sequence of the 1918 virus in those cadavers? Because we know those people were killed from 1918 influenza. And so in fact, that's what they did. They went and they also had a bunch of tissue samples that were taken that had been stored since 1918 in the US military lab or something that they had taken. And they took genetic sequence from these cadavers and they took genetic sequence from these samples, and they were able to piece together the 1918 influenza. They recreated the 1918 influenza virus. Okay? And of course that should, raise some real ethical questions as far as, is that an appropriate thing to do? Should we be trying to recreate this very, very pathogenic virus? This is the original paper published in the journal Science in 2005, where they talked about recreating the 1918 Spanish flu virus. So they actually made it, and that's where that information that I was showing you, that's where those studies came from, because they've used that virus with lab animals. They've infected lab animals to learn more. And of course, on the one side, you can always argue there's a lot of benefit that comes from this, okay? So we've got lots of new publications. We've learned a lot about how the virus works, and we're working towards possibly developing a vaccination for 1918 influenza. This is a paper from a couple of years ago by that same group, looking at using a vaccine they had created and showed some protective effect against 1918. But, you know, and this is at the Centers for Disease Control, so there's a lot. This is like a very, very restricted use. There's only like 2 people that have access to it. And of course, there's a lot of safeguards in play to make sure that this doesn't get out. But it really begs the question, you know, is something like that worth it? I don't know what the answer is, but I think it's a really interesting question. You know, one of the things, you know, it's a little bit cheesy, but, you know, in Jurassic Park, the one guy says, you know, they were so busy thinking about whether they could, they never stopped to think whether they should. And that's, you know, I think where we're at with a lot of this stuff is we can do it, we have the technology to do all this stuff nowadays, but is it something that we want to do? Do we want to have this back out? I mean, this terrible pathogen that killed 50 million people, do you want this around again? And some people would argue, you know, yeah, there's a lot to be gained from it, and also we could probably argue that if something like, you know, another virus similar to 1918 got out again, it would be a whole different story because we have things like Tamiflu now, we have much better communication, preventing its spread and things like that. But that still begs the question of, is it worth doing in the first place? And so just something for you guys to think about. These are the sort of issues that we're all going to be dealing with as we get better and better as a society about our work with genetics and being able to recreate some of these things. You know, I just saw a couple months ago, they're doing the same thing. They're going to take samples and try to recreate the woolly mammoth. Those are the type of things that, you know, we should be doing. I think it's a really interesting ethical question. So I'll kind of leave it there, and hopefully you guys have some questions. Anything else related to influenza? If you'd like to know anything, I'm happy to try to answer.
Book, is it kind of like the Hades Factor book? Have you ever read that one?
I have not read the Hades
They
Factor.
discuss the Ebola virus and the
Okay.
Spanish influenza both, and it's like set in modern time. I was wondering if that was kind of like that. Or,
Is it fiction?
I believe so, but
Yeah.
it's got a lot of facts in it.
Yeah.
So.
No, that sounds interesting, but I have not read that one. But
What's it
no,
called? What's that called? It's called the Hades Factor.
this,
Factor?
Yeah, they had a mini series on television for it too. I don't remember who wrote it, but.
this is all nonfiction. So it's all, I mean, there's all, you know, resource, like citations and stuff in the back, so, this is as close as John.
But it's kind of like interwoven, you said, with, you know, like a lot of historical stuff too.
Yeah.
Like the science and the history.
The whole first chapter is all about the development of medicine in this country from, you know, the Four Humors up to
Mhm.
modern medicine.
I don't know if you read, the Immortal Life of Henrietta Lacks,
Yeah.
but I
Yeah.
thought that was fantastically done because, you know, you could read it and I feel like you were really just reading about science.
Yeah.
You weren't really, you know,
Yeah. I think this is similar, you know, along
Yeah.
those same lines. And yeah, that's another really good book. I talk about that in the classes.
yeah.
So.
Okay, so you said that, you said this was H1N1 in 1918. And so was there really not another like big resurgence of H1N1 until 2009? Was it really,
Well,
I
it's,
mean, little bits of it here and there, but not really a really big,
right. So you will see small amounts of cases of these different strains, but it's kind of confusing when they use the like H1N1 stuff, because technically, you know, what was in 2009 was an H1N1,
but not the same thing as what was in 1918.
but not the same thing, no.
Okay, because my question was kind of leading to, you know, as far as you said, of course, the 5% of people that were eliminated
Right.
because they couldn't sustain it, they
Yep.
couldn't, you know, but then the rest of the population then was either had it or exposed to it and developed immunity.
Yeah,
And so, you know, in long enough, at least, you know, that much of the population to be able to wait until the virus was no longer, you know, super active in the population. So, my question kind of then leads to, you know, like about, using vaccine. And, I mean, typically, I don't typically, there, some vaccinations, yes, absolutely, but I don't typically, you know, vaccinate, for influenza, and haven't with my kids, except for, a couple years ago when the H1N1 was out, you know, because they were so, you know,
well,
insistent about that,
Yeah.
and,
Yep.
and my mom gets on my case all the time, and I say, like, even this past winter, when, you know, was supposedly a bad flu, and I said, nope, you know, we're building our own immunity over here. So we kind of argue back and forth about that, and,
yeah, I mean,
and I just wonder if enough immunity was built in the population, the ones that survived, if you think that, you know, it sustained the population for so many years, and then we saw this resurgence almost 100 years later.
I think there's something, I mean, that immunity is not gonna be passed on.
Right, of course,
So,
right.
Yeah, and you see
But
that.
as the people that had survived started to die off and stuff, and then maybe
Yeah.
we became, as a population, we became more susceptible.
Yeah, I mean, and that's not just something that you see with influenza. You know, a lot of people are really worried about the smallpox, and one of the reasons that people are concerned about that is because all the people were vaccinated for that up until 1950 or 60 or something. But then, as all those people die, we were losing anyone that had any protective effect against smallpox, and so there's concern, you know, if that would get released, it would be like a brand new virus, nobody would ever have any protective immunity against it. Same thing with influenza, if you have a certain strain that's in the population, you would have some immunity. However, those strains change every year, and so I would caution you to read too much into, I had it this year, and so I'm gonna be protected next year.
No,
It's
I
not-
understand the how,
Right,
you know, I understand that.
But I mean, I think, you know, the big issue with influenza is people that are pregnant, people that are elderly, or people that are very young.
Uh-huh.
You know, those are the populations that